Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. Earlier today we had two fantastic sessions, one from Liam Tong talking about how you can secure your workloads on Google Cloud Platform, and another one from Tim Sell talking about data lakes. In this session, Gaurav Anand is going to talk to us about open source data processing on Google Cloud Platform. Gaurav has direct management experience managing a platform which accepted 1 trillion messages per day. Remember, at any time you can ask a question below, and we have technical experts ready to assist. With that, I'll hand it over to Gaurav Anand here in Singapore.
Hello everyone. Welcome to Cloud on Air webinar series. I'm sure you might be enjoying, and learning a lot from the sessions which we had in past few days. So today I'm going to talk about, open source data processing on Google Cloud Platform. So, before even getting started, just to, highlight what we are going to discuss in today's session. So we're going to talk about, the open source Apache and Hadoop ecosystem. They're great tools. But they bring a lot of complexity in terms of management, usage, and multiple other things. We are also going to talk about open source on Google Cloud Platform. I would give an introduction on Google Cloud Dataproc, and we would be even seeing a live demo of Google Cloud Dataproc, and just we'll learn how powerful and how easy it is to use. Post that, I will be discussing the new features of Cloud Dataproc, which we just recently announced, and at the end we'll see we'll help you with the resources with which you can actually quickly learn and speed up yourself on Cloud Dataproc. So talking about open source, so the Apache Spark and Hadoop ecosystem is a huge ecosystem. I come from a background where I've seen this technology in last 6.5 years, and it has grown enormously. So if you just Google the 2017 big data landscape, you might see tons of components and tons of technologies. It just comes up with a huge architecture diagram with small components which are vast enough. So we call it open source, but open source is not always simple. It brings in a lot of complexity in terms of setting it up, managing, and actually using it. So I'm going to show you a typical Spark and a Hadoop deployment. So for example, you plan to set up your own cluster for your business case. So there are multiple steps involved in that. The first step being you need to configure your hardware. So you need to provision your hardware. You need to configure your servers. And that's only the first step. The second most important step comes in you try and get all the open source components, all the bits and pieces, and then you try to set them up, optimize your existing open source libraries. And after running a certain set of processes, then you might actually start running your jobs on the cluster. So this process is not a linear process. You might end up using your cluster only maybe, let's say, after a few weeks or even after a month. So it's, even though it's open source, but we still see that setting up and running a cluster and using it, it's not fairly simple. The second important aspect which comes is scaling. I come from a background where I have seen a lot of on-prem implementations, and scaling is one big problem which every enterprise faces. The moment you get your cluster up and running, you start planning for future. You start planning, okay, what would my utilization in terms of resources and capacity maybe a year down the line, or maybe 2 years or 3 years. And then you start building a lot of monitoring tools and scripts on top of your existing system, and then you start collecting a lot of metrics, and you use those metrics, and then you kind of decide on the scaling aspect. So as I mentioned, your scaling again could take days to weeks, and it might even sometimes your entire data processing. The other important aspect is that you always have to babysit your utilization. There can be times in the day wherein your cluster might be utilized completely, or it might be underutilized. So when actually you're implementing a cluster for for solving your business cases, you actually are spending a lot of money, and you don't want to just end up keeping your cluster cold and not using it all the time, because there are a lot of resources which goes in a waste if you are not using it properly. So eventually you're not paying for what you're using. So you should be actually in a position that whatever you're spending in terms of capacity and resources, you're actually utilizing that in your processing. So these are some of the issues which generally come up when you try to set up a Hadoop cluster on-prem, and you also even try to set up multiple clusters, because in any enterprise scenario, or even with a smaller company, you might not just need a one cluster. You might need multiple clusters. You might need like a dev cluster, a production cluster, and a staging cluster. And as you start installing a lot of components, the complexity keeps on increasing, and you end up losing a lot of time just spending on bringing your cluster up and scaling it out and babysitting the utilization. So I'm going to talk about how Google Cloud Platform solves this problems which we discussed in terms of setting up clusters and actually utilizing them to their full potential. So on Google Cloud Platform, we support vendor-based Hadoop solutions. So if you're using Cloudera or Hortonworks or Mapr, you can just bring them in to Google Cloud Platform. So there might be multiple benefits with that. A, you are already tied up to a vendor. Second, you might get low-cost virtual machines on Google Cloud Platform, which can be significantly lower in terms of cost compared to the on-prem hardware which you're using to support all these softwares. You also can get preemptible VMs, which I'm going to talk about in later part of our discussion. But yeah, coming back to the original discussion, if you are tied up to any of these vendors, you can just lift and shift them and bring them to Google Cloud Platform. So we offer a variety of steps wherein you can bring your data processing from your on-prem to Google Cloud Platform, or from existing Hadoop or an existing Google Cloud to Google Cloud Platform. So as I mentioned about vendor Hadoop, so you can just lift and shift and utilize the power of our virtual machines and our storage systems. We also, so basically we started the Dataproc journey by offering something called as BDUtil. So these are open source scripts present on GitHub, and you can bootstrap your clusters, and you can configure your clusters using command line scripts. And we had a lot of customers who actually started the using BDUtil and then eventually moved to Cloud Dataproc. But with Cloud Dataproc, we thought we could do a bit better. So we just want you to focus on your data and on your business logic, and not to worry about scaling the cluster, or keeping the cluster up and running, monitoring the resources and stuff like that. So Cloud Dataproc is a fully managed Hadoop and Spark cluster, and I'm going to talk about the different components which we have, which comes as part of the standard installation, and what else could you configure and install in Cloud Dataproc in the coming slides. So basically this slide talks more about how we map the open source technologies within the Apache, Spark and Hadoop ecosystem to our Google Cloud products. So pretty much the standard Hive, Pig, Kafka, Spark, Scoop, Zookeeper, Google Cloud Dataproc, like you can run all of them on Google Cloud Dataproc. We also have a set of different products and components which kind of complement the existing open source ecosystem. For example, HBase. So we have Cloud Bigtable, which complements HBase. If you're using some kind of a data processing framework, let's say Beam, Crunch, or Flume, we have cloud data flow. For example, if you're tied up to Impala or Sentry or HDFS, we have equivalent products with which you get even a better performance and overall better utilization of your cluster. Apart from these products which are listed, we also have like different products on around the edges, which kind of supports your entire migration from your existing setup to Cloud Data Proc. So coming back to the open source technology, so the current ecosystem which we have, which we generally refer to as Apache Spark and Hadoop ecosystem, has been inspired all these years by the Google papers. So we celebrated 10 years of Hadoop last year, and it was really great. We have seen a lot of innovations coming in, and there are a lot of new projects which are coming and new ecosystem components which keep coming every 3 months. Google is also very passionate about open source, and one very good example which I could give you is Apache Beam. So Google has been actively contributing to the Apache Beam project, which gives you ability to create your batch and streaming pipelines with just using one SDK, one model, and you could run that pipeline on any of your data processing frameworks, let's say Spark or Flume or even Cloud Data Flow. So let's talk more about Dataproc. So in general, Dataproc is fast, and it's a fully managed service, and you just need to focus on your data and take advantage of Spark and Hadoop. So these are the 3 key points which I would like to highlight in terms of the effective Cloud Dataproc. It's fast, it's easy, and cost effective. I'm sure like pretty much all of you who are watching, everyone who has either used Hadoop in the past or are using Hadoop, you just want these 3 things to actually enhance your productivity and your existing use cases. So at the start of this discussion, we had a slides wherein I showed like right from the start, when you try to set up an on-prem cluster, you configure your hardwares, then you install the operating system, then you kind of optimize, and then actually there comes a stage wherein you start using your Hadoop cluster. But with Cloud Data Proc, you can spin up a cluster in minutes. So you just need to submit a form, or you just need to submit, there is a web page wherein you just fill in some of the details, and then you have your cluster up and running. There are multiple ways in which you can bootstrap your cluster. You can do it via console, which is part of the demo. You can also use Dataproc API, and you can also use gcloud commands to bootstrap or change some configurations of a cluster. So you can imagine like from days to weeks to even months, we have our clusters ready in just a span of minutes, which actually saves a lot of time and a lot of effort, and you start actually gaining a lot of benefit by saving all that time and just putting into your development cycles and getting most out of the cluster. So Dataproc in itself is, we just don't want people to tie up with Dataproc. We want to bring the open source ecosystem to Google Cloud Platform. So just by using Spark and Hadoop, it's not going to solve, or even the Hadoop ecosystem projects, it's not going to solve all the problem. So what we can do is we can bring Dataproc and open source technologies together, and you can actually utilize the capabilities of existing Google Cloud Platform products in your Dataproc cluster and get maximum benefit out of that. For example, if you use persistent disk and as like HDFS as your storage, you can use cloud storage because you get very high throughput, and you can use cloud storage as a federated like storage system which can be utilized by all different components within the platform. And if you're using HBase, you can use Bigtable. And for example, if you have your enterprise data warehouse set up in BigQuery, you can use BigQuery in your Dataproc Hadoop jobs, and again you can write it back to BigQuery or to cloud storage or to Bigtable, pretty much to within. So the point in showing this slide is that we just don't want you to be tied up with Spark and Hadoop. You could get much benefit out of just integrating Dataproc with other components within Google Cloud. So there are multiple ways of migrating to Cloud Dataproc. So I would just start with a very simple way of migrating your existing Hadoop implementation or your existing Hadoop clusters to Cloud Dataproc. You just need to make sure that your data lake or your data is present in Google Cloud Storage, and you just need to change your file prefix. So for example, if you're using HDFS and your data is in Google Cloud Storage, you just need to change the prefix from HDFS to Google Cloud Storage, and you're good to use Cloud Dataproc. So this is the most simplest and the most effective way, and probably that's the only way I would say of lift and shift to Cloud Dataproc. So this is just an example, a Spark code from the Spark examples, and you could see that if I would have to run this job on Google Cloud Platform, the only thing which I would have to do is to change the file prefix or from HDFS to Google Cloud Storage. So yeah, that's the only change I need to do technically in order to run all of my jobs on Cloud Dataproc. Let's talk about more on how Google Cloud Dataproc works under the hood, because I'm sure when we anyway start a discussion about Hadoop or distributed systems, people are also very much interested in knowing how it works internally rather than just using it. So that's why we're going to discuss that as well. So Cloud Dataproc is built on existing Google Cloud Platform technologies. It's built on top of the compute engine. So we have various ways of setting up your cluster within Google Cloud Platform. The standard way is to have a master node and have multiple worker nodes. We also have high availability, wherein you can have multiple master nodes and then you have worker nodes. So all of them are compute engine based. One very important thing to note is that with Google Cloud Platform, you get something which is called as preemptible VMs. Now, what are these preemptible VMs? Preemptible VMs are the virtual machines which are present in the Google Cloud, in Google data centers as a spare capacity. So with preemptible VMs, there is a trade-off. The maximum lifespan of a preemptible VM is just 24 hours, and whenever Google wants it, it can be taken back. But with preemptible VMs, you get a fairly low cost. In most of the cases, almost 80% reduction in the existing cost of VMs, and you can run all your compute intensive workloads. So apart from that, the existing Hadoop implementations or setups, they come with a persistent disk, but most of our customers, they use Google Cloud Storage just because of some of the advantages which I just mentioned too. We'll talk about more on cloud storage and its advantages in the coming slides. We also have API endpoints, which are basically 3 API endpoints for client interaction with our Hadoop clusters. So one is to create and modify the clusters through the console. We have a job submission API which you can leverage and submit your jobs and view the status and kind of do some kind of a debugging, and also for operations, if you want to just know how your cluster is behaving in terms of utilization or monitoring. So these are the 3 endpoints which are available with Google Cloud Dataproc, and pretty much any Hadoop implementation which comes in, they need all these 3 API endpoints. In order to interact with Cloud Dataproc, there are 3 ways. We have a developers console which we call as our Google Cloud console. We also have a cloud SDK which we call it as a G Cloud SDK, and you can also SSH to your master or worker nodes. So basically, like depending on the audience, either of these three choices can be made in terms of interacting with your Dataproc cluster. Okay, pricing, that's one of the most commonly asked questions when it comes to any of the products. So with Cloud Dataproc, what you are being charged of is mostly the compute and storage, and we bill by minute and not hour, and that's a very important point to note, because some of your clusters which you might create can be ephemeral, so it can be short-lived. So you can just use a cluster for, let's say, 10 minutes, and you pay only for 10 minutes and not for the entire hour. There's also a premium 1 cent premium on the CPUs. So as we are discussing about cost effectiveness, there is an O'Reilly article. I have kind of ducked the the link at the footer, which actually compares GCP with Amazon EMR, and it says that most of our jobs run pretty fast and they're like very cost effective. So overall, if you compare Cloud Dataproc with the existing cloud providers for Hadoop, our jobs and our clusters run much faster. Our clusters bootstrap very fast, and again, as I discussed in terms of the pricing, it's fairly low. It's very effective if you bring in all these three features into one. So it's a good read. You can probably just Google it out, and you will have that link, and you can get a comprehensive like coverage of which compares both EMR and Dataproc. Okay, coming back to the components. So as I discussed initially, like if you just Google out Big Data Ecosystem 2017, you get tons of components, and like I've seen in the years, the number of components keep on increasing, So we actually maintain our own repository of Cloud Dataproc. There is an open source project called as Apache BigTop, and we most of our distributions which we build of our own distributions and are all present on the URL which you just see on your screens. So basically, we don't want to convolute your cluster by just installing multiple components and tangents of components on your cluster. What we give is the standard installation, which comes with the most commonly used components like Hive, Pig, Spark. Apart from that, we don't stop you from installing any other component on your Dataproc cluster. So basically, we also do versioning on our side. So we maintain like different versions of Dataproc and the sub versions of the individual projects in that. So we don't want to stop you from going ahead and installing let's say Flume or Zeppelin or any other component in Dataproc. You totally can. Okay, so I'm going to do a quick demo of Cloud Dataproc. So in this demo, we are going to do a few things. We are going to spin up a decent sized Hadoop cluster. I won't call it as a very big cluster, but a decent sized cluster. We are also going to query around 500 million rows worth of data. It's an open source airline performance data. We're going to the output of the query in Google Cloud Console, and we're going to read the cluster. So let's move on to the demo. Okay, so this is the form or the console page in Google Cloud Platform wherein you can create a cluster. So I can just quickly run through like the different options and privileges you get when you try to create a cluster using this web page. So you can give a name to your cluster. So you can have like multiple clusters. You can have a production cluster. You can have a development cluster, a staging, or even a lightweight cluster with just one node. So let's give a name to this cluster. Okay, so if I just click on the zone, you see there are different zones which you can choose when you actually try to create a cluster. So Cloud Data Proc is present everywhere where compute engine is there, and like going forward, you might, as like more data centers come up, across different regions, you might even see this list growing. So you can choose any region which your business is mostly present on. So I'm going to choose just US Central. Coming to the machine type, so in terms of master node, we give 3 types of options. We have the standard, which is one master and multiple workers. We recently announced a new feature which you can use, just have a single node cluster. You can have a one master and one worker on just a single machine. That's very good for development exploration, for lightweight data science, and it's like you don't need to create a full-blown heavy cluster to do that. We also support high availability based on YARN and HDFS, wherein you can have multiple masters and workers. So in this case, I'm just going to have the standard one master and multiple workers. So I'm going to select that. Since I'm not going to use much of the persistent disk, so I'm just going to reduce the the persistent disk size, because my data is present in Google Cloud Storage. Coming to the worker nodes, so we have different types of worker nodes, and based on your requirement, you can choose or select any kind of worker nodes. A lot of people ask this question: what if I want to create a cluster which is 6 CPU and 28.6 gigs of memory? You totally can. So we have an API endpoint with which you can actually customize your CPUs and customize the specific RAM settings, and all these machines which you see are non-shared CPUs. For this demo, I'm just going to use N standard 8 CPU because it works well in this case, and I'm going to set up a fairly large cluster. I'm going to create a 200 node cluster, and since I won't need much of the persistent disk, so I'll just use 50 gigs of persistent disk. There are some advanced options as well. So with Dataproc, you can create your own network, and you can limit it within a network. So you can create like different types of network from the Google Cloud Networking console. In this case, I'm just going to use the default network. Coming back to the image version, so couple of slides back I was talking about the different kind of versions and the supported versions of different components. So we maintain the versions regularly. Cloud Data Proc has very frequent releases. So if you just go to Cloud Data Proc release page, you will find a list of all the recent release distributions, the versions, and the subversion of the different ecosystem projects. So I'm just going to take the default, which is the latest version. Now there is something which is called as initialization action. So basically, if you want to install a component which is which doesn't come with the standard installation, you totally can. In this case, to demonstrate that, I'm going to install Presto along with my existing cluster. So once you fill up this form, the only thing which you need to do is just click on create. So it starts creating your cluster. So and I will show it to you that the cluster comes up very fast. So a 200 node cluster will just comes in few minutes of time. Now moving on to submitting a job. So there is a separate a form or a page using which you can actually submit your jobs. There are other ways to do that. You can use our API, Dataproc API, to submit your jobs. You can also do it via command line using G-Cloud console. In order to demonstrate today, I'm just going to use the Google Cloud console to actually submit a job. So if you click on submit a job, it would give you a complete list of clusters you have. In my case, I just have one cluster. So let's switch back and see the progress of our cluster, and you can see that it's still coming up. Now talking about the job submission console, so currently we support six types, but there are infinite ways in which you can run jobs or submit different type of component or subcomponent related jobs on Cloud Data Proc. So if I would have to just run a Spark SQL, I could just have a file which should be on Google Cloud Storage, or I could just paste the entire code in the console and just run it. For this demo, what I'm going to do is that I'm going to use Pig, and I'm going to use Pig to shell out it to Presto and create an external table on Hive and run some aggregate queries on Presto. So basically I'm kind of abusing Pig, but the reason why I'm doing this is that we don't want you to be limited to a standard approach. You can follow n number of approaches and n number of infinite ways to submit your jobs to the cluster. So the logic which I want to run is based on a file which is present in my cloud storage. So I'm just going to specify that in my query file. If you have additional parameters which you want to pass on to your job, you totally can. You can add different parameters, and the only thing which you need to do is just click on submit. So the moment you do this, so while we were talking, our cluster is still getting provisioned. So you can see, like, since I have submitted this job, so you can see the real-time output on the console over here. So once the cluster comes up completely, you can see that the logs on the screen, and alternatively you can also view, you can submit your jobs through the G Cloud console, and you can view the progress from that. Okay, in this case it's just taking a bit while, but yeah, in the meanwhile, I just wanted to show you one more important thing, which is the data proc initialization action. So we do maintain initialization action. So in this case, like, I kind of used Presto. So we have a bunch of different initialization actions which you can use. Apart from this, if you want to do some standard or custom installation on top of the existing Dataproc cluster, you totally can. So all these Dataproc initialization actions are maintained regularly. You will see changes and commits, additions very frequently. So what we try to do is we try to always keep the latest versions up, and whatever is not useful, we just try to move it away. But yeah, you get a great flexibility in having like n number of components installed in your Dataproc cluster. Okay, there seems to be some issue with the bootstrapping of the cluster. So meanwhile this comes up, maybe what we'll do is we'll continue with the slides. Okay, so in this case what we are trying to do is just create a cluster with 200 nodes with 1600 yarn cores and 4.7 terabytes of RAM, and in just one single click. So as I discussed, there are like alternate ways in which you can kind of bootstrap or create clusters, but yeah, this is the most simplest way to do that. And since, for example, if I use this cluster only for 10 minutes, so the total money which I would be paying is just $12.85. So this is what is compared, the price which you see is compared to other cloud vendors like EMR or even HD Insight. So you could see that there is a substantially very low cost which comes up when you actually use Dataproc cluster. So yeah, so we have been talking a lot in terms of the open source components and how complex it is, but we see that how we try to bring in those complex the complexity of the open source system to a minimal level in Cloud Dataproc. So I have few suggestions which might be very useful for people who want to lift and shift to Dataproc, or people who are using Dataproc clusters. So you might want to split your clusters into multiple ones. So you just don't want to have one single cluster which you want everyone to continue to use it. you might want to spin out separate clusters so that you can kind of segregate use cases, and you basically don't have to kind of spend additional effort in babysitting the existing single cluster and then the utilization. The other important aspect is that you should try separating different environments. So you should have like a different development and a production environment. The only benefit which I would see here is that if you create multiple clusters, you often need to bootstrap data from one cluster to another cluster or even to multiple clusters. But within Google Cloud Platform, since all of your data would be sitting on cloud storage, so this acts as a federated data source. So you can even though you create multiple clusters, but still you can have the same Google Cloud Storage bucket using all these clusters. Another important thing is that you should try to create and delete clusters very often. So some people ask like, how feasible is that? So in Google Cloud Platform, it's totally feasible. You can use Apache Airflow to kind of schedule and join different components of your jobs, create a cluster, and then end up deleting it. So let's say you have a batch job which runs every 2 hours, so you need not have your cluster up and running for entire 2 hours. You can just create a cluster, delete it, and just move on. So whenever you need, you do that. We talked a lot about Google Cloud Storage. So what's the benefit of moving from persistent disk, which is HDFS, to Google Cloud Storage? One, which we talked about, Google Cloud Storage can act as a federated data source. So you don't limit the usage to Cloud Data Proc, but it could be used by BigQuery, Bigtable, or any of the components within Cloud Platform. You get a very high throughput and very optimum read and write performance. There has been some recent improvements and recent innovations which have been launched on Google Cloud Storage, and we want Dataproc to be benefited from that. So we always suggest to use Dataproc with Google Cloud Storage, and a lot of customers are doing that. In terms of job submission API, there are various ways. There are infinite number of ways you can submit your jobs. In our case, we highly recommend to use Jobs API. You might not want to always SSH to your gateway node or to your master nodes and submit jobs, because some of your folks in your team might not be okay with that. So you can use our Jobs API. Another important thing is that you can scale your clusters anytime. So let's say you have a cluster up and running, so you can kind of make additions in terms of adding nodes, removing nodes without a zero downtime. You can also build custom virtual machines, which I just talked some time back, and of course you can utilize the power of preemptible virtual machines in Dataproc cluster. You could see the job output in real time. In our case, there were some technical issues, but yeah, when you submit a job, you can kind of see all the output in real time. You can also through command line and through APIs see the same console results and the console output. Customizing your cluster. So I just showed you the different type of initialization actions we have and we maintain. Apart from that, let's say if you have to make small additions or small changes to some of the core properties files of your Hadoop cluster, you totally can. You need not even SSH to your master machine to do that. You can just use our API tools, and you can just specify the property and the value you want to be modified or to be changed, and that's very simple and very helpful. I'm going to talk about few new Dataproc features which were just recently announced in our annual Google Cloud conference next, a month and a half back. So we have come up with something called as restartable jobs. So at times there are like multiple jobs which fail often due to different reasons. One very good example is the streaming jobs. So we might you might not want to again restart them by yourself. So we have that feature now in beta, wherein with each and every job you can specify the number of retries you want to have per hour, or the maximum number of failures your job can withstand. So that is something which you can totally do now. We recently announced that you can use GPUs with the clusters. So again, GPUs is something which is kind of evolving now, and like this shows that any innovation which happens within Google Cloud Platform, we try to bring that to the required products which could get benefited with that. So yeah, so the maximum number of GPUs which you can have is 8, and you can fairly run all your compute intensive Spark workloads using GPUs. We also have single node clusters, which I demoed to you some time back. So if you just want to use Dataproc for exploration or like lightweight data science, you can totally do, or even for education or for training, you need not spend a lot of money in just creating big fat size clusters. Regional endpoints and private IP. So with the current like couple of months back, we announced the regional endpoints. So you can actually limit your Dataproc clusters to specific zones. So if you want to interact only with a specific zone, let's say Europe or US, you can do that. You can just specify that in your cluster when you bootstrap your cluster, and your cluster would be pretty much limited in that space. We also have been like receiving a lot of feedback from our existing customers that whenever you create a cluster, there used to be a public IP attached to it. So now you with the current feature, which is in beta phase, you don't actually expose your public IP, you just have the private IP. So this is very useful, especially for the enterprises who don't want to kind of limit, don't want to expose the IP addresses. So just coming towards the end of the discussion, so how to get started with Cloud Dataproc? We have tons of options and tutorials using which you can kind of get started with Cloud Dataproc. As I mentioned, we do frequent releases, so you can just go through our release notes, and we always love feedback. So any feedback, any improvement in terms of features or usability or stuff like that, you totally can. Okay, thank you.
All right, thanks a lot, Gaurav. That was really, really informative. You packed a lot of information into a very small presentation. So there were quite a few questions actually coming from the audience. One is, of course, people thinking about sort of the level of configurability that they would have with a Hadoop cluster on Dataproc. So how complex is it to install custom components?
In my demo, I was just trying to show that you can install multiple type of components. So apart from the ones which are present in our Dataproc initialization actions, let's say if you want to install Zeppelin, so you can even install that. So in terms of configurability and installing custom components, it's very easy. Unlike some of the vendors wherein if you just want to update one single component, you need to update the entire distribution. So you can use different type of versions between the projects. You can use lower versions, higher versions, and you can basically install anything on our Dataproc clusters, and it's very easy. You don't have to kind of spend hours in configuring it, and you just follow the standard installation step and you get that working.
Okay, so I know you and I have had some previous conversations about sort of the differences between like running it on premise and versus running it in the cloud, and one of the things sometimes people feel sort of the out-of-the-box instances that we provide might be restricting. So can you tell us about sort of custom VMs with Dataproc?
Yeah, so apart from the standard VMs which we provide at the cluster creation time, Using our command line tools and through our API, you can even have a custom VM. You can build a custom VM by yourself. So if you want to configure the RAM or if you want to configure the CPUs, you totally can. And one more important information which I just missed is that we just announced 64 core VMs. So so now you can even run Dataproc with 64 core VMs in future. So so apart from the standard VMs, you totally can customize your own virtual machines and run whatever you want to.
Fantastic. And as you mentioned, GPUs now as well.
Yeah. So your GPUs as well. So if you have like any high compute intensive workloads like Spark or Spark ML, so you can utilize the power of GPUs and run that.
Right. So really, it's about sort of right sizing those instances and making sure that you're only paying for what you actually need.
So we are pretty flexible on that aspect. We don't tie you up with a specific instance type or with a specific version of a product. We just give you the cluster with all the basic and the required features and all the standard components which are most commonly used. On top of that, you can configure and install anything.
Okay, so I guess along with that, right, so now you've got this sort of new capability in the cloud and you can sort of provision these Hadoop clusters quite quickly. Now you're talking sort of about having like mixed workloads as well and doing all of that in sort of these multi-tenancy environments. So normally they would sort of, in a Hadoop environment, they would fight for those resources. So how does Cloud Dataproc handle that?
Yeah, that's a very good question. So in my past experiences, I worked in environments which were multi-tenant. So even though you have a fairly huge cluster, but let's say there is a team who dedicatedly wants to run Spark, or there is a team who dedicatedly wants to run Presto. So you often end up segregating your big cluster into different zones, but you still end up using the same cluster because at the end it's a machine, right? So in that case, you can segregate your clusters in Dataproc. You can create separate clusters for separate use cases. So if you have a machine learning team who wants to run Spark ML, you can just create a 10-node Spark ML cluster and use that. If you have a use case to run Presto, you can create a separate Presto. So in that way, you are still using some kind of a multi-tenancy because you have one federated source of data in cloud storage. But yeah, your one team is actually not affecting the other team's usage of the cluster, and they can scale up themselves whenever they need to.
Okay, awesome. So I guess this sort of really feeds into the next one. So what are the operational and economic benefits of using something like Cloud Dataproc?
So in terms of operational, as you saw in the slides, you don't have to spend days or even months in bringing your cluster up, and you don't need to build separate monitoring tools to capture the utilization or storage usage of your cluster. We have Stackdriver as a one component which you can plug in with any of the Google Cloud platform and build a monitoring on top of that. So operationally, you don't have to spend any time on the operational side. In terms of economic benefits, yes, you just need to concentrate on your data. We bill by minute and not by hour. So as I mentioned, if you have jobs which run in batch for let's say 5 minutes, 10 minutes, you need not have your cluster up and running for the entire day. So in that way, there are a lot of benefits. Plus, you can use cloud storage, which is which gives you a very high throughput and performance. So yeah, I would say operationally and economically, there are a lot of benefits with Dataproc.
All right, awesome. So I've got one more question for you, even though it's not on the slide. It was a question that came in a bit late, so I didn't have a chance to put it on here. Talking, and this has come up several times, I think, through a lot of our presentations when we're talking about data, is data lifecycle management. Right? So what are some best practices that people can use to sort of manage this data so it doesn't get unwieldy inside of their Hadoop cluster, so they can make sure that they're maximizing the efficiency by minimizing the amount of data that they're actually storing there?
Yeah, so one important aspect would be to use cloud storage. Don't tie yourself to HDFS because because you're depending on Hadoop clusters just for the processing, be it batch processing or real-time processing. So have your data in Google Cloud Storage as one federated system. You can have your entire data lake on cloud storage, which could be used by multiple other projects within the cloud platform. So that way you can get a maximum benefit out of, in terms of data lifecycle management. And again, you get integration of data proc with other components within cloud platform. So then you actually get the maximum benefit out of data proc, because just by using Spark and Hadoop, you don't solve all the problems of big data.
Yeah, and Google Cloud Storage has fantastic lifecycle management, allowing you to set policies and things on that data, and managing it through nearline and cold line storage.
Yep.
Okay, awesome. Thank you so much, Gaurav. I know that I learned a lot, so thank you very much. So thank you so much for joining us, and thank you so much for your questions as well. If you take a look at your screen, there are different things that you can do in order to learn more. So number one is obviously there's always an option to get certified. Secondly, you can take a look at some of our hands-on labs available from Quick Labs and from Coursera. You can contact us if you have any further questions. There are free tiers available for a lot of our services, so check that out and start playing with those today so you can get a better understanding of how to use Google Cloud Platform. And we also have our learning site to help you with your training. So thank you so much. We do have 2 more sessions today. If you watched them earlier and just want to watch them, just want to join us again for another live session, please do. If you haven't seen them, I suggest you register for those now. Feel free to send those to your friends and colleagues as well. Thank you very much.
Thank you.